In today's video, I would like to introduce a very nice problem of Estonian Mathematical Olympiad edition 1998. Here is the following setup. Our goal, we are going to solve this following equation. We have x squared plus 1 equals log of the base 2 of x plus 2 minus 2x, okay? Before we start solving this equation, we are going to determine the domain range of this equation. So notice here, inside of the log must be positive, okay? So we have x plus 2 must be strictly superior than 0. Equivalent x must be strictly superior than minus 2, okay? Like this. By solving this equation, I'm simply going to move this 2x to the left hand side of this equation. I will have x squared plus 2x plus 1 equals log of the base 2 of x plus 2, okay? This one is written on the form of the quinary square, which is x plus 1 quinary square. We will have x plus 1 quinary square equals log of x plus 2. As we know, the log of the base 2 of x plus 2 is a log of x plus 2 is divided by a log of 2. So by multiplying both sides by log of 2, I will get x plus 1 quinary square is multiplied by a log of 2 equals log of x plus 2, okay? So if I'm going to bring this one to the original one, I will get a log of 2 to the x plus 1 quinary square as an exponent, okay? So this one equivalent log of 2 to the x plus 1 quinary square equals log of x plus 2, okay? By eliminating a log function from both sides, I will get 2 to x plus 1 quinary square equals x plus 2. So I have ended with this expression. So if you take a look at the left hand side of this equation, we have the exponent x plus 1 quinary square, but the right hand side we have x plus 2. So it's very hard to solve this equation without doing the substitution, okay? So let's consider x is a positive integer, okay? Like this. There is y as a rational number, okay? Such that I'm going to put x plus 1 quinary square equals 2y, like this, okay? So I'm going to change this equation in terms of y. So this one is giving us 2 to the 2y equals x plus 2. By applying the square root on both sides, I will get x plus 1 equals square root of 2y. By adding number 1, I will get square root of 2y plus number 1 separately, okay? Now I'm going to move over number 1 to the left. I will get 2 to the 2y minus 1 equals square root of 2y, okay? The left hand side of this equation is written on the form of the difference of two squares, so I'm going to transfer this one into the product. Okay. So this one is giving me 2 to the y minus 1 factor 2 to the y plus 1 equals square root of 2y, okay? Now the next thing up, I'm going to square both sides. So by doing that, I will get square here. I'm going to take off the square root. It's giving us this one. If you take a look at the substitution, we know the left hand side of this equation is an integer, okay? That means the right hand side of this equation must be an integer as well. So which means 2y is an integer. It's a positive integer, okay? With y is a rational number, okay? So since the right hand side of this equation is an integer, the right hand side of this equation is an even, but the left hand side of this equation is an odd, which means this is odd, this is odd, because this one is even minus odd is giving us odd. This one even plus odd is giving us odd, which is impossible to have one side even, the other side odd, okay? So in order to maintain this equation, to make everything works correctly, the right hand side of this equation must be odd. In order to have this one odd, we must give y half, and also y must be equal 0. So this one is going to take two cases. So I will have plus 1 equals 0 or 1. Okay, if it's 0, which means y is going to take 0. Okay, or y is going to take half, like this. Okay, so this one is going to take, must be superior to 0, like non-negative rational number. So must be a non-negative rational number because it includes 0. Okay, so the only way to maintain this equation is when it equals to 0 or 1. Okay, since the right hand side of this equation equals 0, that means the left hand side of this equation equals 0 as well. But this term is strictly superior than 0. Okay, that means this term equals 0. Okay, which means 2 to the y minus 1 equals 0, equivalent 2 to the y equals 1, equivalent y equals 0. So we have y equals 0 by using this substitution, which means x plus 1 quinary square equals 0. In the other word, x equals minus 1. So we get the first solution. So the second solution, when we have y equals half, implies I'm going to use the same substitution expression. I will have x plus 1 quinary square equals 2 is multiplied by half, which equals 1. Okay, by taking the square root on both sides, I will get here x plus 1 equals plus or minus 1. Okay, which is 1 or minus 1. X plus 1 equals 1 when we have x plus 1 is superior equal to 0. Okay, we have x plus 1 equals minus 1 when we have x plus 1 is strictly inferior than 0, like this. Okay, so I'm going to force this minus 1 to be out of this possibility. So because I have x plus 1 equals minus 1, which means x equals minus 2, which is impossible because it is out of the domain range, because we have x is strictly superior than minus 2, so which this one is rolled out of this possibility. So we must take the first choice, which is x plus 1 equals 1, equivalent x equals 0. So this is the second solution as well. I get two solutions. I get x equals minus 1, I get x equals 0. Okay, I have done this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.